Our planet, a vibrant tapestry of life, is at a turning point. The intricate web of ecosystems, from the dense rainforest to the vibrant coral reefs, is facing unprecedented challenges. The evidence is undeniable. Climate change, driven by human activities, is altering the very fabric of our world. Industrial emissions, rampant deforestation, and the relentless expansion of urban areas are all contributing to this crisis. From the melting polar ice caps to the increasing intensity of storms, the consequences are far-reaching and increasingly evident. The Arctic ice is vanishing at an alarming rate, and the frequency of devastating hurricanes and storms is on the rise. Human-caused climate change, otherwise known as anthropogenic climate change, is primarily driven by activities that increase the concentration of greenhouse gases in the atmosphere. These gases trap heat and lead to global warming. Activists around the world are raising their voices, demanding change and taking action to protect the environment. We must understand the urgency of this crisis and embrace our responsibility to protect the delicate balance of life on Earth. Scientists are working tirelessly to provide us with the data and insights needed to make informed decisions. There is now overwhelming evidence suggesting that global warming is driven by human activities. Climate change and global warming is a combined result of the burning of fossil fuels, deforestation and poorly managed land use, intensive agriculture and livestock production, industrial processes and poor waste management, and our over-reliance on transportation. The natural world, in all its beauty and complexity, is under threat. Species that once thrived are now on the brink of extinction, and pristine landscapes are being altered beyond recognition. The very systems that sustain us, the air we breathe, the water we drink, the food we eat, are being disrupted at an alarming rate. Pollution is contaminating our rivers, droughts are ravaging farmlands, and cities are choking under layers of smog. The consequences of inaction are dire, with rising sea levels threatening coastal communities and extreme weather events causing widespread devastation. Floods, hurricanes, and wildfires are becoming more frequent and more destructive. It is a sobering reality, but one that we must confront head-on. Communities are coming together to rebuild after disasters, and scientists are continuously analyzing data to better understand the changes we are facing. The interconnectedness of life on Earth means that changes in one part of the system ripple outwards, impacting countless other species and ecosystems. The loss of a single species can have cascading effects throughout an ecosystem. The loss of biodiversity, driven by habitat destruction and climate change, is a stark reminder of the fragility of our planet. Wetlands are shrinking, forests are being cleared, and animals are losing their habitats. We are witnessing the sixth extinction event in Earth's history, and this time, humans are the driving force. Industrial activities are destroying habitats at an unprecedented rate, leading to the extinction of countless species. Shifts in the distribution of plant and animal species as they seek favorable climates. Coral bleaching and the loss of biodiversity are already observable consequences. Vital ecosystem processes like pollination and natural water filtration are being disrupted. The future of our planet hinges on the choices we make today. Embracing renewable energy sources like wind and solar power can significantly reduce our carbon footprint and help mitigate the effects of climate change. We have the power to chart a different course, one that prioritizes sustainability, conservation, and a harmonious relationship with nature. Urban garden initiatives and protected wildlife reserves are just a few examples of positive steps we can take. By understanding the challenges we face and embracing solutions, we can create a future where both humanity and nature can thrive. Innovative technologies and community-driven projects are paving the way for a more sustainable world. The time for complacency is over. The time for action is now. Global leaders, activists, and everyday citizens must come together to address the climate crisis and ensure a livable planet for future generations. The Earth's climate has always been in flux, shaped by natural forces over millennia. From the ice ages to warmer interglacial periods, our planet has experienced significant changes. These natural cycles have been driven by factors such as volcanic eruptions, variations in solar radiation, and shifts in the Earth's orbit. The greenhouse effect, a natural process, plays a crucial role in regulating our planet's temperature. Without it, Earth would be too cold to support life as we know it. This process involves the absorption and re-emission of infrared radiation by greenhouse gases in the atmosphere. Certain gases in the atmosphere, like carbon dioxide, methane, and water vapor, trap heat from the sun. These gases allow sunlight to enter the atmosphere and reach the Earth's surface, where it is converted into heat. This heat is then radiated back towards space, but some of it is trapped by the greenhouse gases, warming the planet. This trapped heat keeps Earth warm enough to support life. It creates a stable climate that allows ecosystems to thrive and provides the conditions necessary for human civilization to develop and flourish. Imagine these gases acting like a warm blanket around the planet, maintaining a delicate balance. This balance is crucial for sustaining the diverse forms of life that inhabit our world. However, human activities have significantly amplified this natural process, tipping the balance and leading to a warming planet. The Industrial Revolution marked the beginning of a new era, where the burning of fossil fuels became the primary source of energy. Earth's average surface temperature has risen by approximately 1.1 degrees Celsius since the late 19th century, with much of this warming occurring in the past few decades. Since the 1950s, the upper ocean heat content has also risen. The average global sea levels have risen, while the Arctic sea ice level has decreased. The burning of fossil fuels, coal, oil, and natural gas for energy is a primary culprit. These activities release vast amounts of carbon dioxide and other greenhouse gases into the atmosphere, far exceeding natural levels. When burned, these fuels release massive amounts of carbon dioxide and other greenhouse gases into the atmosphere, trapping more heat than necessary. This excess heat leads to global warming, causing shifts in weather patterns and more extreme weather events. CO2 is particularly important because it stays in the atmosphere for a long time, centuries, creating a long-term warming effect. Measurements of different forms of carbon isotopes demonstrate that this increase is due to human activities. The increase in CO2 is largely from combustion of fossil fuels. This is known because fossil fuel emissions have a low 13 carbon fraction and no 14 carbon fraction. Furthermore, scientists have measured CO2 levels in air extracted from ice cores. This analysis indicates that the current concentrations of CO2 are substantially higher than they have been in at least 800,000 years. The excess CO2 from fossil fuel combustion and deforestation has disrupted the carbon cycle, as natural processes that could rebalance it cannot keep up with the rapid rate at which human activities are releasing CO2 into the atmosphere. Consequently, a significant portion of this CO2 builds up in the atmosphere, where it will persist not just for decades or centuries, but for thousands of years. Human activities are also contributing to the rise in other greenhouse gases, such as methane and nitrous oxide. The increase in global surface temperatures since 1900 aligns with detailed calculations of how the observed rise in atmospheric greenhouse gases, along with other human-driven changes, affects Earth's energy balance. Deforestation, the clearing of forests for agriculture, logging and development, further exacerbates the problem. Forests play a critical role in absorbing carbon dioxide, acting as natural carbon sinks. They store this carbon in their biomass, helping to mitigate the greenhouse effect. When forests are cut down or burned, this stored carbon is released back into the atmosphere, accelerating the greenhouse effect. This not only contributes to global warming, but also leads to the loss of biodiversity and disruption of ecosystems. Agricultural practices, particularly livestock farming, also contribute significantly to greenhouse gas emissions. The demand for meat and dairy products has led to an increase in livestock populations. Methane, a potent greenhouse gas, is released in large quantities from livestock, particularly cattle. This gas is produced during digestion and released through belching and flatulence. Although its concentration in the atmosphere is lower than carbon dioxide, CO2, methane is much more effective at trapping heat. Over a 20-year period, methane is about 84 to 87 times more potent than CO2, and over a 100-year period it is around 36 times more effective in trapping heat. This strong heat-trapping ability makes methane a critical player in global warming. Methane absorbs infrared radiation, heat, emitted from Earth's surface and re-radiates it back towards the planet, preventing heat from escaping into space. This process enhances the greenhouse effect, leading to global temperature rise. Methane stays in the atmosphere for a shorter period than CO2, about 12 years on average, but during this time, it exerts a much stronger warming influence. After it breaks down, methane can be converted into CO2, which continues to contribute to warming. The scientific evidence showing methane's role in global warming is well established and supported by various methods of observation, modeling, and measurement, such as direct atmospheric measurements, ice core date, and satellite observations that can detect methane concentrations in the atmosphere from space. Additionally, the production of fertilizers and the use of certain agricultural chemicals release nitrous oxide, another potent greenhouse gas. These practices contribute to the overall increase in greenhouse gas concentrations, further disrupting the delicate balance of our climate. The consequences of a warming planet are becoming increasingly apparent in the form of shifting weather patterns. The Earth's climate system is incredibly complex, and changes in temperature can have cascading effects on weather events around the globe. Various factors, including natural climate variability like El Niño and La Niña, influence individual extreme weather events, making it difficult to directly link any specific event to human-induced climate change. However, research can determine if a warming climate increased the severity or likelihood of such events. While evidence suggests that climate change can influence El Niño in several ways, there are still uncertainties regarding the exact nature of this relationship. El Niño events release a lot of heat from the ocean into the atmosphere, temporarily boosting global temperatures. During strong El Niño events, the global average temperature can spike. Climate change, which is already warming the planet, may make these temperature spikes more pronounced. This, in turn, may lead to feedback loops, where the increased global temperatures further influence ocean-atmosphere interactions. Some evidence suggests that El Niño events could become more intense as global temperatures rise. These changes manifest in a variety of ways, from more frequent and intense heat waves to altered precipitation patterns. El Niño tends to bring heavy rainfall to parts of the Americas, and in a warmer climate, the atmosphere holds more moisture. This can lead to more intense storms and flooding during El Niño events. Certain conditions that support strong thunderstorms capable of producing tornadoes are expected to become more common as temperatures rise. But there is still uncertainty regarding other factors influencing tornado formation, such as shifts in wind patterns both vertically and horizontally. Regions like Southeast Asia and Australia often experience drought during El Niño. Climate change, which is driving more frequent and intense heat waves and drying conditions, could worsen these El Niño-related droughts and wildfires. The increase in extreme weather events is one of the most striking impacts of climate change. Climate change can alter atmospheric circulation patterns, including the position and strength of jet streams, which can influence where and when heat waves occur. For example, weakening or shifting jet streams can cause weather patterns, including heat waves, to become more stationary, leading to prolonged periods of extreme heat. Heat waves, periods of abnormally high temperatures, are becoming more common and severe, posing significant risks to human health, agriculture, and ecosystems. The scorching temperatures can lead to heat stroke, dehydration, and exacerbate respiratory problems. Long-term temperature records show a clear upward trend in global average temperatures, with many of the hottest years on record occurring in the past 2 decades. A 2021 study showed that the extreme heat wave in the Pacific Northwest of North America, which led to record temperatures in parts of the US and Canada, would have been virtually impossible without the influence of human-caused climate change. For instance, regions like Europe and North America have seen dramatic increases in the frequency of heat waves. A study on the 2019 European heat wave found that climate change made the event up to 100 times more likely than it would have been without global warming. Changes in precipitation patterns are another hallmark of climate change. Some regions are experiencing more frequent and intense rainfall, leading to flooding, landslides, and soil erosion. Conversely, other regions are facing prolonged droughts with devastating consequences for agriculture, water resources, and ecosystems. These shifts in rainfall patterns can disrupt agricultural cycles, leading to crop failures and food shortages. The warming atmosphere also holds more moisture, leading to more intense storms and hurricanes. Warmer ocean temperatures provide more energy for these storms, making them more powerful and destructive. Coastal communities are particularly vulnerable to the impacts of these storms, facing risks from storm surges, flooding, and erosion. The oceans and ice caps, vital components of the Earth's climate system, are bearing the brunt of climate change. These natural wonders, which have existed for millennia, are now undergoing rapid transformations that are both alarming and unprecedented. The impacts are visible on a massive scale, from the melting of glaciers and ice sheets to rising sea levels and ocean acidification. These changes are not just isolated events, they are interconnected phenomena that amplify each other, creating a cascade of environmental challenges. As the Arctic warms, frozen ground known as permafrost thaws, releasing more methane that was previously trapped and further exacerbating the warming effects of atmospheric methane. Warmer temperatures and changing rainfall patterns can also increase methane emissions from wetlands. These changes have profound implications for marine life, coastal communities, and the overall health of our planet. Marine ecosystems, which are already fragile, are being pushed to their limits, while coastal areas face the threat of inundation and erosion. The melting of glaciers and ice sheets, particularly in Greenland and Antarctica, is a major contributor to rising sea levels. These regions hold vast amounts of ice, and their accelerated melting is a clear indicator of the warming climate. As temperatures rise, these massive ice formations are melting at an accelerating rate, pouring vast amounts of fresh water into the oceans. This influx of fresh water not only raises sea levels, but also disrupts ocean currents and weather patterns. Satellites like NASA's ICESat, Ice, Cloud and Land Elevation Satellite, and ESA's Cryosat-2 use laser or radar altimeters to measure changes in the surface height of ice sheets and glaciers over time. These measurements provide accurate data on the thinning of ice sheets in Greenland and Antarctica. Evidence shows that both the Greenland and Antarctic ice sheets have been losing mass since the 1990s, with Greenland losing over 280 billion metric tons of ice per year, and Antarctica losing about 150 billion metric tons per year on average. Long-term monitoring programs, such as the World Glacier Monitoring Service, WGMS, collect data from glaciers worldwide. Most monitored glaciers show a persistent negative mass balance, meaning they are losing more ice than they are gaining. For example, Alaskan glaciers and those in the Himalayas, Andes, and Alps are retreating rapidly, with many losing tens of meters in thickness each year. Before and after photographs of glaciers taken over several decades show clear evidence of retreat. Iconic glaciers like those in the Alps, Alaska, and Patagonia have shrunk dramatically, with many now reduced to a fraction of their historical size. The consequences of rising sea levels are far-reaching, threatening coastal communities, infrastructure, and ecosystems around the world. Cities and towns built along coastlines are particularly vulnerable, facing the risk of flooding and storm surges. Ocean acidification, a less visible but equally concerning impact of climate change, is occurring as the ocean absorbs excess carbon dioxide from the atmosphere. This process alters the chemical balance of seawater, making it more acidic. Ocean pH has been measured for over 30 years, providing a direct record of acidification. These measurements, conducted by ocean monitoring programs, show a clear decline in pH, especially in surface waters. Since the beginning of the industrial era, the ocean's pH has dropped by about 0.1 units, which corresponds to a 26% increase in acidity. The Global Ocean Acidification Observing Network and various other programs regularly collect data on ocean pH, carbonate ion concentration, and related chemical parameters, confirming the acidification trend in all major oceans. When CO2 dissolves in seawater, it reacts with water to form carbonic acid, H2CO3. Carbonic acid then dissociates into hydrogen ions, H+, and bicarbonate ions, HCO3, leading to a decrease in pH, more acidic conditions. The increased hydrogen ion concentration from CO2 absorption reduces the availability of carbonate ions, which are essential for many marine organisms, like corals and shell-forming species, to build calcium carbonate structures. Studies show that carbonate ion concentrations have significantly decreased over time, making it harder for these organisms to survive. The ratio of carbon isotopes, carbon-12 and carbon-13 in ocean water is changing due to the increased absorption of CO2 from fossil fuel emissions. This isotopic signature provides strong evidence that human activity is directly contributing to ocean acidification. These diverse lines of evidence together confirm that ocean acidification is a direct consequence of human-induced CO2 emissions and that it poses a significant threat to marine ecosystems. As the ocean absorbs carbon dioxide, it becomes more acidic, threatening marine life, particularly organisms with shells and skeletons made of calcium carbonate, such as corals, shellfish, and plankton. These creatures are essential to the marine food web, and their decline could have ripple effects throughout the ecosystem. Coral reefs, often called the rainforests of the sea due to their biodiversity, are particularly vulnerable to ocean acidification and warming waters. These vibrant ecosystems are home to countless species, many of which are found nowhere else on Earth. These ecosystems provide habitat for a vast array of marine life, support fisheries, and protect coastlines from erosion. The loss of coral reefs would not only be a blow to biodiversity, but also to the human communities that rely on them for food and protection. However, as ocean conditions change, corals are experiencing bleaching events where they expel the symbiotic algae that provide them with food, leading to their death. This phenomenon is becoming more frequent and severe, threatening the survival of coral reefs worldwide. The loss of these ecosystems would have devastating consequences for marine life and human communities alike. Climate change is real, it's happening now, and human activity is the driving force behind it. Rising temperatures, extreme weather, melting ice caps, and the loss of biodiversity all point to a crisis we can no longer ignore. But the good news is, we have the power to change the future. By embracing sustainable energy, protecting our ecosystems, and making smarter choices, we can help reverse some of the damage caused by anthropogenic climate change. Thank you for listening. I hope you enjoyed the video. If you would like more science stories, then please subscribe to Science Curious.